Hikes 203. Let's work on exercise 16.2. For this one, we're rolling 4 distinguishable 6-sided dice, and we want to know the probability of getting 3 even and 1 odd number. Well, one of the ways we could solve this is just with our definition of probability. So we know that the probability of an event is just the cardinality of that event divided by the cardinality of the sample space. So let's work on how we could use that definition. The cardinality of our event, well, I think we should figure out how many ways can we roll 4 dice and get 3 even and 1 odd number. So to start, we can decide, well, which of these dice is going to be odd? And we have 4 choose 1 options to do that. And then once we've picked our odd die, we should probably pick what the dice actually are. So for that odd die, there's 3 options to have an odd number on a 6-sided die. So that's going to be 3 options there. And then we've also got 3 even dice and 3 options for each of those. So 3 to the 3rd. That looks good for our event. Now, how about the sample space? How many ways can we roll 4 dice and get any outcome? And so there's 6 options for each die, and we're rolling 4 of them. So it seems like 6 to the 4 would make sense for our total. And that's going to give us a probability of 4 choose 1 times 3 times 3 to the 3rd, all divided by 6 to the 4th. But that's not the only way we could solve this problem. The other thing we can do is we can realize, well, wait a second, this is just a binomial distribution. We've got 4 dice, and we're rolling each of those dice, and we want to know the number of odd dice, which we can think about as the number of successes. So we've got n equals 4, and we're saying that the probability of a success is just 1/2. You have a 1/2 probability to roll an odd number on a fair 6-sided die. And we're looking for, well, what is the probability that we have exactly 1 success or exactly 1 odd number? And we know if it's a binomial distribution, then the probability of getting k successes is n choose k times p to the k times 1 minus p to the n minus k. And so if we apply that definition to our situation, we're going to have p x equals 1 is just 4 choose 1 times 1/2 to the 1, which is for our odd numbers, and then times 1/2 to the 3rd, which is for our even numbers. And we can see that the answer we got with our first method and the answer we got with this shortcut of the binomial distribution is exactly the same.